Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of this triangle equals to 13 units, side BC equals to 14 units, side AC equals to 15 units. And our mission is to find out the area of the green shape. Okay, so first of all I will present to you a new wall, and we'll implement the new wall in our drawing. The rule is rule number 4. According to rule number 4, the area of triangle ABC is equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of this triangle, that is to say it is the perimeter over 2. The perimeter of any triangle is the sum of its side lengths. Here we have in the drawing triangle ABC. We know that the length of side AB is equal to A units, side BC equals to B units in its length, and side AC equals to C units in its length. So the perimeter of triangle ABC is A plus B plus C, and when we divide the perimeter by 2, we get the semi-perimeter S. So S equals to A plus B plus C over 2. The length of side AB is A, the length of side BC is B, and the length of side AC is C. Repeat again that the area of this triangle, triangle ABC, that could be any triangle, equals to the square root of S. S is the semi-perimeter, times S minus A, times S minus B, times S minus C. Okay, now we implement the new formula in our drawing. We define the length of side AB as A, and we know that A equals to 13 units. We define the length of side BC of this triangle, triangle ABC as B, and we know that B equals to 14 units in its length. And finally, we define side AC of this triangle, triangle ABC as C, and we know that C equals to 14 units, to 15 units. C equals to 15. So I write it down. According to our definition, A equals to 13, B equals to 14, and C equals to 15. In the next step, we calculate the semi-perimeter of this triangle, triangle ABC. According to the new formula, the semi-perimeter S of triangle ABC equals to A plus B plus C over 2. So S equals to A, that is 13, plus B, that is 14, plus C, that is 15 over 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter S of our triangle, triangle ABC equals to 31 units, and A equals to 13, B equals to 14, and C equals to 15. According to the new formula, rule number 4, we get that the area of our triangle ABC is equals to the square root of S times S minus A times S minus B times S minus C. So the area for a triangle ABC is equals to the square root of S. S is 21 times S is 21 minus A, that is 13, times S is 21 minus B, that is 14, times S is 21 minus C, that is 15. So the area of triangle ABC equals to the square root of 21. 21 minus 14 is 8. 21 minus 14 is 7. And 21 minus 15 is 6. So the area of triangle ABC, according to rule number 4, is equals to the square root of 21. We will substitute 21 by 3 times 7 times 8. We will substitute 8 by 2 times 2 times 2 times 7 times 6. We will substitute 6 by 3 times 2. Okay, so the area of triangle ABC, according to rule number 4, is equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2. So finally, the area of triangle ABC, according to rule number 4, is equals to the square root of 3 times 3 is 3, times the square root of 7 times 7 is 7, times the square root of 2 times 2 is 2. Again, we have 2 times 2, 4 times, so the square root of 2 times 2 again is 2. So 3 times 7 is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So finally, hold on, the area of our triangle ABC, according to rule number 4, is equals to 84 square units. Okay. Repeat again, the area of our triangle ABC, according to rule number 4, is equals to 84 square units. In the next step, I present to you And you roll rule number 6 and implement rule number 6 in our drawing. According to rule number 6, the radius of a circle that blocks triangle ABC is equals to R equals to A times B times C over 4 times the area of triangle ABC that is blocked by the circle. So in the drawing we have a circle, inside this circle we have this triangle ABC that is blocked by the circle. We also know that the length of side AB of triangle ABC equals to A unit in its length, side BC equals to B units in its length, and side AC equals to C units in its length. We define the radius of this circle as capital R. According to this rule number 6, the radius capital R on this circle that blocks triangle ABC equals to A times B times C, that is the multiplication of the side lengths by each other, over 4 times the area of this triangle ABC that is blocked by the circle. Okay, so we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. So we define the radius of this circle as capital R. So actually, according to rule number 6, the radius capital R of this circle that blocks triangle ABC will be equal to A times B times C over 4 times the area of this triangle ABC. And we have already found out that the area of triangle ABC equals to 84 square units. So it is over 4 times the area of triangle ABC. So the radius R equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC, that is actually 84 square units. Here we divide both the numerator and the denominator of this expression by 14. So in the numerator we have 14, and 14 over 14 is 1, so we left only the numerator, we left only with 13 times 15 over, in the denominator we have 4 times 84 over 14 is 6. In the next step, we divide both the numerator and the denominator of this expression by 3. And we get that in the numerator we have 13 times 15 over 3 is 5. So in total, in the numerator we have 13 times 5 over, in the denominator we have 4 times 6 over 3 is 2. So in total, in the denominator we have 4 times 2, that is 8, and in the numerator we have in total 13 times 5, that is 65. So actually, we found out that the radius of this circle capital R, according to rule number 6, is equals to 65/8 units. Our mission is to find out the area of this grain shape. From the drawing it is very easy to see that the area of the grain shape in total it is equals to the area of the circle minus the area of triangle ABC. So I'll write it down. The area of the grain shape in total it is equals to the area of the circle minus the area of triangle ABC. So the area of the grain shape is equals to the area of the circle. The area of the circle is pi r square minus the area of triangle ABC. I repeat again that we've already found out that the area of triangle ABC equals to 84 square units. Okay, so the area of triangle ABC is 84 square units. The area of the circle is equals to pi times r square. R equals to 65/8, therefore r square is 65/8 square minus the area of the circle that is 84 square units. Actually, this expression, pi times 65/8 square in total, it is equals to 207.394 square units, that is the area of the circle, minus the area of triangle ABC, that is 84 square units, and 207.394 minus 84, it is equals to 123.394 square units. So if you found out that the area of the grain shape is equals to 123.394 square units. Repeat again. The area of this grain shape equals to 123.394 square units. So we finished with the first method. In the next step I will present to you how to find out the area of this grain shape according to the second method. In the second method, we will do a construction, that is to say from point A, we will draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and BC as M. We will define the length of side AM as H. We will define the length of side BM as X. it is given us the question that side BC of triangle ABC equals to 14 units. According to our definition, BM equals to X. Therefore, the missing side CM, equals to CB minus MB. CB is 14, MB is X, so in total, CM equals to 14 minus X. So I write it down, CM equals to 14 minus X. In the next step, I will copy the right triangle ABM in a new page, and we will implement on this right triangle ABM the Pythagoras theorem. So actually, this is the right triangle A and B that I call it from the original drawing. Side A equals to H according to our definition, side BM equals to X also according to our definition. And the hypotenuse AB of this triangle ABC equals to 13 units in its length according to what is given as the question. Here, by PT is the relation for Pythagoras theorem. So, in the right triangle ABC, according to the Pythagoras theorem, we get that AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169, and it is equal to AM squared. AM is 8, therefore AM squared is 8 squared, plus BM squared. BM is X, therefore BM squared is X squared. So in conclusion, we found out that according to equation number 1, 169 equals to 8 squared plus X squared. Here we subtract X squared from this equation, equation number 1, and we get that according to equation number 1, 8 squared equals to 169 minus X squared. In the next step, I'll copy the right triangle AMC in a new page, and we will implement the Pythagoras theorem in this right triangle AMC. By PT is the relation for Pythagoras theorem. Side MC equals to 14 minus X. The hypotenuse AC equals to 15 units. So actually, this is the right triangle AMC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle AMC, AC square equals to AM square plus MC square. Okay. AC is 15. Therefore, AC square is 15 square, that is 225. And it is equals to AM square. AM is 8, therefore AM square is 8 square plus MC square. MC is 14 minus X, therefore MC square is 14 minus X square. Here we subtract 14 minus X square from this equation number 2, and we get that according to equation number 2, X square equals to 225 minus 14 minus X square. This is according to equation number 2. Repeat again. Found out that according to equation number 2, X square equals to 225 minus 14 minus X square. While according to equation number 1, we have already found out that X square equals to 169 minus X square. So actually we have two different expressions for H square. In the next step we'll create equation number 3. Equation number 3 states that H square according to equation number 1 must be equal to H square according to equation number 2. Okay? So H square according to equation number 1 is equals to 169 minus X square, and it must be equal to H square according to equation number 2. H square according to equation number 2 equals to 225 minus 14 minus X square. So I actually found out that according to equation number 3, 169 minus X square equals to 225 minus 14 minus X square equals to 14 square, that is 196, plus X square minus 2 times 14x, that is minus 28x. So I actually found out that according to equation number 3, hundred 69 minus x squared equals to 225. Here we'll open the brackets and we get here minus 196 minus x squared, and we have minus times minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation. So x squared will get cancelled. Minus x squared will get cancelled. So in this side of the equation, after we cancel minus x squared, we're left only with 169. And it is equals to 225 minus 196 is 29 plus 28x. So here we subtract 29 from this equation number 3, and we get that according to equation number 3, 169 minus 29 is 140. That is equals to 28x. Here we divide this equation number 3 by 28, and we get finally that x equals to 140 over 28 is 5. So x equals to 5 units. According to equation number 1, x squared equals to 169 minus x squared. That is to say, h squared equals to 169 minus x squared. But x is 5, therefore x squared is 5 squared, that is 25. So actually found out that h squared equals to 169 minus 25 is 144. So h squared equals to 144. Here we take a root out of this equation number 1, and finally we get that h equals to the square root of 124, that is 12. So h equals to 12 units in its length. And write down here that h equals to 12 units in its length. In the next step, we will define the center of this circle as O. And we will join points O and A together by a straight line. Point O is the center of the circle. Point A is the point of the circle itself. Therefore, OA is the radius of this circle. We define the radius of this circle as capital R. So OA equals to capital R. We will extend the radius AO by a straight line until it touches the circle. And we define the touching point of the extended radius AO with this circle as P. Actually, we extended the radius AO, that is absolutely a straight line, by a straight line. When we extend a straight line by a straight line, the result is a straight line. So AP is a straight line. AP is not only a straight line, but it is a straight line that touches the circle at points A and P. Therefore, AP is a chord that passes through point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. So I write it down here. That chord AP is the diameter of the circle. We know that the diameter of any circle is twice as long as the radius. So the radius of this circle is capital R, therefore the diameter AP must be equal to 2 times capital R, or 2 times R. Here point O is the center of the circle, point P is the point of the circle itself, therefore OP is also the radius of this circle, that is equals to capital R. You can see here that chord AP in total equals to R plus R, that is 2r, that is the diameter of this circle. In the next step, we join points P and C together by a straight line. By joining points P and C, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have actually rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I'll repeat on rule number 7 again. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing, we have peripheral angle ACB that rests on AB, and AB is the diameter of the circle. Therefore, this peripheral angle ACB equals to 90 degrees. So we can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, peripheral angle ACP according to rule number 7 must be equal to 90 degrees. We have also rule number 8 here that we can implement in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing we have peripheral angle ADB that rests on chord AB, and we also have another peripheral angle ACB that rests on the same chord AB. So because of the fact that those two peripheral angles rest on the same chord AB, therefore they must be equal to each other. That is to say, if peripheral angle ADB equals to theta, then peripheral angle ACB must be also equal to theta. So we can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC, but we also have another peripheral angle ABC that rests on the same chord AC. So those two peripheral angles rest on the same chord AC, therefore they must be equal to each other. That is to say, if we define peripheral angle APC as theta, then this peripheral angle ABC that rests on the same chord AC must be also equal to theta. According to rule number 8, of course. In the next step, we will focus on the right triangle ABM. On the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, if you focus on the right triangle, triangle APC, in this right triangle, triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we prove that the right triangle, triangle ABM is similar to the right triangle, triangle APC. So I'll write it now. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So I write it down. This is angle ABM. And it is equal to this angle, that is actually angle APC. Repeating it. Angle ABM in triangle AMB equals to angle APC in triangle APC. They are both equal to theta, therefore they are equal to each other. In addition, those two angles they are both equal to 90 degrees, therefore they are equal to each other. So this is angle AMB. That is equal to this angle, that is actually angle ACP. Repeat again. Angle AMB in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MAB. And it is equals to this angle, angle CAP. Repeat again, angle MAB in triangle ABM equals to angle CAP in triangle APC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in triangle A and B are correspondingly equal to all the three angles in triangle ACP. Therefore, those two triangles are similar to each other according to angle similarity rule. So I'll write it down. The right triangle ABM is similar. This is the sign of similar to the right triangle APC. According to angle similarity rule. Okay, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AB in triangle ABM over AP in triangle APC is equals to AM in triangle ABM over AC in triangle ACP. Repeat again. We derive that AB over AP equals to AM over AC. AB is 13 and AP is the diameter of the circle that is equals to 2R, and it is equals to AM. AM is 12 over AC, that is 15. So in conclusion, I found out that (13 over 2R equals to 12 over 15. Here we'll cross multiply this equation and we'll get that 13 times 15 equals to 12 times 2R. Here we divide this equation by 12 and we get that 2R equals to 13 times 15 over 12. Here we'll divide this equation by 2 and finally we get that R, that is the radius of the circle, equals to 13 times 15 over 2 times 12. Here we divide both the numerator and the denominator of this expression by 3, and we get that in the numerator we have 13 times 15. So 15 over 3 is 5. So in total, in the numerator after we divide it by 3, we have left only with 13 times 15. In the denominator we have 2 times 12 over 3 is 4. So in total, the denominator after we divide it by 3, we left only with 2 times 4, that is 8. In the numerator we have 13 times 5, that is 65. In conclusion, we found out that the radius of this circle R equals to 65 over 8 units. So I write it down. The radius R of this circle equals to 65 over 8 units. From the drawing it is very easy to see the area of the green shape equals to the area of the circle minus the area of triangle ABC. So I write it down. The area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. Okay. So actually the area of the green shape in total, it is equals to the area of the circle. The area of the circle is pi r squared minus the area of triangle ABC. What is the area of triangle ABC? From the drawing it is very easy to see that the area of this triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h over 2. So I write it down. The area of triangle ABC equals to the base, that is BC, times the height to the base, that is h over 2. The area of the circle is pi r squared, and we have already found out that r equals to 65 over 8, so it is pi R is 65 over 8, therefore R squared is 65 over 8 squared. So in total, the area of the circle equals to pi times 65 squared over 8 square units minus the area of triangle ABC. The area of triangle ABC is BC, that is 14, times H, that is 12, over 2. Okay? This expression in total, pi times 65 over 8 square equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to 14 over 2 is 7, and 7 times 12 is 84. So in total, the area of triangle ABC equals to 84 square units. And the area of the green shape in total, it is equals to 207.394 minus 84. That is actually 123.394 square units. Okay, so the area of the green shape, according to the second method also, is equals to 123.394 square units. And that is the answer for our question. I said again, the area of this green shape according to the second method also, it is equals to 123.394 square units. Okay, so in the next step, I will summarize the lecture. I'll start with the first method, of course. In this lecture, our mission was to find out the area of this green shape. In the drawing, we have a circle. Inside this circle, we have triangle ABC. We know that side AB of this triangle ABC equals to 13 units, side BC equals to 14 units in itself, and side AC equals to 15 units in itself. Again, our mission is to find out the area of this green shape. Okay, so in the first method, I presented to you rule number 4, and we implemented rule number 4 in our drawing. According to rule number 4, the area of triangle ABC is equals to the square root of S times S minus A times S minus B times S minus C. Here, S is the semi-perimeter of this triangle ABC. In this triangle ABC, side AB equals to A units, BC equals to B units in itself, and side AC equals to C units in itself. The semi-perimeter of this triangle ABC equals to the perimeter that is A plus B plus C over 2. So S equals to A plus B plus C over 2. I repeat again that the length of side AB is A, side BC equals to B units in itself, and side AC equals to C units in itself. So the area of triangle ABC equals to the square root of S. S is the semi-perimeter that is A plus B plus C over 2, times S minus A, times S minus B, times S minus C. So we can actually implement rule number 4 in our drawing. First of all, we define side AB by SA, and A is 13. We define side BC of this triangle ABC as B, and B is 14. and we define side AC of this triangle ABC as C, and we know that C equals to 15 units in its length. Repeat again. According to our definition, A equals to 13, B equals to 14, and C equals to 15. In the next step, we calculated the semi-perimeter of this triangle ABC. According to rule number 4, the semi-perimeter of this triangle ABC equals to the perimeter that is A plus B plus C over 2. Because again, the semi-perimeter S of our triangle ABC equals to A plus B plus C over 2. A is 13, B is 14, and C is 15. When we divide it by 2, we get the semi-perimeter S. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So in conclusion, we found out that the semi-perimeter of this triangle ABC, the semi-perimeter S, equals to 21 units. So according to rule number 2, the area of this triangle ABC must be equal to the square root of S times S minus A times S minus B times S minus C. I remind to you that A is 13, B is 14, and C is 15, and S is 21. So the only thing that is left to do is to put the data inside the formula for the area of triangle ABC, and we find out the area by this formula. So the area of triangle ABC according to this rule number 4 must be equal to the square root of S. S is 21 times S minus A. S minus A is 21 minus 14. S minus B is 21 minus 14. And S minus A is 21 minus 15. So the area of triangle ABC equals to the square root of 21 times 21 minus 14 is 8, times 21 minus 14 is 7, and 21 minus 15 is 6. So in total, the area of triangle ABC equals to the square root of 21 times 8 times 7 times 6. Here we substitute 21 by 3 times 7, we substitute 8 by 2 times 2 times 2, and we substitute, and we have also 7, we substitute 6 by 3 times 2. You can arrange the numbers here differently, and you get that the area of triangle ABC equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. So the area of triangle ABC equals in total to the square root of 3 times 3 is 3, the square root of 7 times 7 is 7, and the square root of 2 times 2 is 2, and we have again the square root of 2 times 2 is 2. So in total the area of triangle ABC equals to 3 times 7 times 2 times 2. 3 times 7 is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in total we found out actually that the area of this triangle ABC equals to 84 square units. Then I presented to you rule number 6 and implemented rule number 6 in our drawing. According to rule number 6, the area of a circle that blocks triangle ABC is equal to R is the radius of the circle that blocks triangle ABC. We know that the length of side AB is A, side BC equals to B units in its length, and side AC equals to C units in its length. So the radius of this circle that blocks this triangle ABC equals to A times B times C, that is the multiplication of the side lengths of the triangle that is blocked by circle. So we'll multiply the side lengths of the triangle that is blocked by the circle by each other over 4 times the area of this triangle ABC. So I can actually implement rule number 6 in our drawing. So according to rule number 6, the radius of this circle that blocks triangle ABC will be equals to A times B times C over 4 times the area of this triangle, triangle ABC. And we already found out that the area for a triangle, triangle ABC equals to 84 square units. I'll repeat again that according to rule number 6, the radius of this circle that blocks triangle ABC must be equal to A times B times C over 4 times the area of triangle ABC. A is 13, B is 14, and C is 15 over 4 times the area of triangle ABC. The area of triangle ABC is 84 square units. Here we divided both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1, so we're left only with 13 times 15. In the denominator we have 4 times 84 over 14 is 6. So in total, in the denominator we have 4 times 6. After we divided by 14, we left only with 4 times 6. So in the next step, we divided both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15 over 3 is 5. So in total, in the numerator we have 13 times 5. And then we divided the denominator of this expression by 3. So in the denominator we have 4 times 6 over 3 is 2. So in total, the denominator, after we divided by 3, we left only with 4 times 2. So we actually found out that the radius of this circle that blocks triangle ABC according to rule number 6 equals to 13 times 5, that is 65, over 4 times 8, over 4 times 2, that is 8. So actually found out that the radius of this circle that blocks triangle ABC equals to 65 over 8. Yeah, capital R equals to 65 over 8. What is the area of the green shape? Our mission is to find out the area of this green shape. The area of this green shape equals to the area of the circle minus the area of triangle ABC. I repeat again. From the drawing, it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square, and we would found out that the area of triangle ABC equals to 84 square units. So the area of the circle is pi r square. R is 65 over 8, therefore r square is 65 over 8 square. So in total, the area of the circle equals to pi times 65 square over 8 minus the area of the triangle ABC, that is 84 square units. In total, this expression equals to 207.394 square units minus the area of the circle, minus the area of triangle ABC, that is 84. So 207.394 minus 84 equals to 123.394 square units. That is actually the area of the green shape. Repeat again. The area of the green shape equals to 123.394 square units. The area of this green shape equals to 123.394 square units. We finished with the first method. In the next step, I presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say from point A we go perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. Then we define side AM as H. And we define side BM as X. We know that BC equals to 14 units, BM equals to X, so CM is BC minus BM. That is to say, CM equals to BC, that is 14, minus BM, that is X. So in total, CM equals to 14 minus X. Okay, then I copied the right triangle A and B in a new page, and we implemented on this right triangle A and B the Pythagoras theorem. So actually, this is the right triangle A and B that I copied from the original drawing. By PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle A and B, AB squared equals to AM squared plus BM squared. So AB is 13, therefore AB squared is 13 squared, that is 169, and is equals to AM squared. AM is 8, therefore AM squared is 8 squared, plus BM squared. BM is X, therefore BM squared is X squared. So in total, we found out that according to equation number 1, 169 equals to 8 squared plus X squared. Here we subtracted X squared from this equation number 1. And finally, we found out that according to equation number 1, 8 squared equals to 169 minus X squared. Then I copied the right triangle AMC in the new page and implemented on this right triangle AMC the Pythagoras theorem. This is the right triangle AMC that I copied from the original drawing. AC equals to 15 units according to what is given as the equation. AM equals to H according to our definition. And we already found out that MC equals to 14 minus X. So here by PT is the version for Pythagoras theorem. In this right triangle AMC according to the Pythagoras theorem, AC squared equals to AM squared plus MC squared. So AC is 15, therefore AC squared is 15 squared, that is 225. And it is equals to AM squared. AM is 8, therefore AM squared is 8 squared, plus MC squared. MC is 14 minus X, therefore MC squared is 14 minus X squared. Here we subtracted 14 minus X squared from this equation number 2. And finally we found out that according to equation number 2, H squared equals to 225 minus 14 minus X squared. This is according to equation number 2, while according to equation number 1, we already found out that H squared equals to 169 minus X squared. So we have two different expressions for H squared. Therefore, we created equation number 3 that says that H squared according to equation number 1 must be equal to H squared according to equation number 2. H squared according to equation number 1 equals to 169 minus X squared. And it must be equal to H squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus X squared. So we have according to equation number 3, we found out that 169 minus X squared equals to 225 minus 14 minus X squared equals to 14 squared, that is 196. Plus X squared minus 2 times 14x, that is minus 28x. Then we open the brackets here and found out that 169 minus X squared equals to 225. After we open the brackets here, we have minus 196 minus X squared, and minus is plus. So it will be plus 28x. So here we have minus X squared on both sides of the equation, so minus X squared will get cancelled. After we cancel minus X squared, in this side of the equation we left only 169. In the other side of the equation we have 225 minus 196 equals to 29 plus 28x. Here we subtracted 29 from this equation number 3, and found out that according to equation number 3, 169 minus 29 is 140, that is equals to 28x. Here we divided this equation number 3 by 28, and finally found out that x equals to 140 over 28, that is 5. So x equals to 5. Then we have equation number 1 that states that x squared equals to 169 minus x squared. That is to say, x squared according to equation number 1 equals to 169 minus x squared, but x is 5, therefore x squared is 5 squared, that is 25. So in total, according to equation number 1, we actually found out that x squared equals to 169 minus 25, that is 144. So according to equation number 1, we found out that x squared equals to 144. we took out of this equation number 1, and finally found out that h equals to the square root of 144, that is 12. So if I found out that AM, that is h, equals to 12 units in its length. In the next step, we define the center of this circle as O. We join points A and O together by a straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as capital R. Then we extended the radius AO by a straight line until it touches the circle. We define the touching point of the extended radius AO in this circle as P. When you extend a straight line by a straight line, the result is a straight line, so AP is a straight line. AP is a straight line that touches the circle at points A and P. Therefore, it is actually a chord. AP is a chord that passes from point O, that is the center of the circle, and we know that any chord that passes for the center of the circle must be the diameter of the circle. So AP is the diameter of the circle, and we know that the diameter of any circle is twice as long as the radius. The radius is capital R, therefore the diameter AP equals to 2 times capital R. Here again we know that point O is the center of the circle, point P is the point of the circle itself, therefore OP equals to the radius of the circle, that is capital R. So we know that in total AP equals to R plus R, that is 2R. AP equals to 2R, that is actually the diameter of this circle. Then we join points P and C together by a straight line. By joining points P and C, we created peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And you know that any chord that rests on the diameter of the circle must be equal to 90 degrees according to rule number 7. I repeat on rule number 7. If a peripheral angle rests on the diameter of the circle, then it must be equal to 90 degrees. Here we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB equals to the size of this peripheral angle ACB is equals to 90 degrees. We can implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, according to rule number 7, this peripheral angle ACP must be equal to 90 degrees in its size. Then I presented to you rule number 8 and implemented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have in the drawing peripheral angle ADB that rests on chord AB, and we have another peripheral angle ACB that rests on the same chord AB. Therefore, those two peripheral angles that rest on the same chord AB must be equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. We actually can implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC, and we have another peripheral angle ABC also rests on the same chord AC. So those two peripheral angles that rest on the same chord AC must be equal to each other. That is to say, if this peripheral angle ABC equals to theta, then the other peripheral angle APC that rests on the same chord AC must be also equal to theta. If you focus on the right triangle APC, in the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in any triangle. Likewise, if you focus on the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Then we proved that the right triangle, this right triangle ABM is similar to this right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually prove that all the triangles in the right triangle ABM are correspondingly equal to all the triangles of the right triangle APC. Therefore, we actually prove that those two right triangles are similar to each other according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that AB in triangle AMB over AP in triangle APC equals to AM in triangle AMB over AC in triangle ACP. I repeat again, we derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle, that is 2R, AM is 12, and AC is 15. Here we cross multiply this equation and found out that 13 times 15 equals to 2R times 12. Here we divided this equation by 12 and found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2 and finally found out that R, that is the radius of this circle, equals to 13 times 15 over 2 times 12. Here we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in total in the numerator we have 13 times 5 over, we divided the denominator also by 3. So it is the denominator we have 2 times 12 over 4 is 3. So in total, in the denominator we have 2 times 4. 2 times 4 is 8, and 13 times 5 is 65. So in total, we found out that the radius of this circle, capital R, is equal to 65 over 8 units. And we know that the area of this green shape equals to the area of the circle minus the area of triangle ABC. I repeat again, the area of the green shape from the drawing is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared minus the area of triangle ABC. What is the area of triangle ABC? The area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h, over 2. I repeat again, the area of triangle ABC equals to the base, that is BC, times the height to the base, that is h, over 2. We have already found out that the radius of the circle R equals to 65 over 8. So if R equals to 65 over 8, it means that R squared is 65 over 8 squared. So in total, pi R squared is pi times 65 over 8 squared minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times h, that is 12, over 2. In total, this expression equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to 14 over 2, that is 7, and 7 times 12 is 84. So the area of triangle ABC in total equals to 84 square units. And 207.394 minus 84 equals to 123.394 square units. So I actually found out that in both methods, the area of this green shape equals to 123.394 square units. Okay, thank you very much.